Kia ora, good evening. Welcome to one more session called Night New Zealand. And tonight we have a special guest, Bobo. How are you?
Yeah. Hi, Marcel. Yeah, thank you. I'm doing well. Thanks for the invite.
Well, thank you for joining. I know that's your early Monday morning here in New Zealand, 8 p.m. And wow, our day is just gone. And now we're just having fun sharing like some content, technical content. And I appreciate like your time, you coming here to share with us this session, right? So generative feedback loops in action.
Yeah,
So what you're covering on this session?
yeah. Thanks for the opportunity, Marcel. The talk is actually advanced level of the Gen AI for those who used already building AI applications using Gen AI approach. There are next level of Gen AI where you can bring and train your AI models with your production data. That's some. There are many other ways how you can train, right? And I'm going to showcase one of the way I found to feed the production and real-time data into your AI applications. And I'm going to demo how that works in .NET application in short.
Nice. Excited about that. .NET, right? I'm a .NET developer. I guess like the
Okay.
audience, we have like a lot of .NET developers in here.
Okay.
Uh, but yeah, excited about that. So, but before we start, Bobo, let me just like introduce the user group. If you're new to Coding Night New Zealand, so you know that we have a purpose. We're a community group of developers. We love coding, we follow best practices on software development, languages, and technologies. In general, more focused on Microsoft stack, but we're open to any tech, to be honest. The intent of this user group is to enable developers with practical knowledge to excel and launch their careers. You're always going to find like great content, and that's going to be useful to you, like with your learnings. If you're coming like with a junior background, or if you're a lead developer, you're always going to find like great content in our sessions. I'd like to mention that we are part of AzureTar.com. We're a group of enthusiasts where we get to share the latest and greatest about like the cloud native space. We're sponsored by .NETFoundation.org, which is an entity that looks after the different open source .NET projects. We're also sponsored by JetBrains, software tooling for developers. And with no further ado, Bobur, I'm just going to give the floor to you.
Thanks, Marcel. I'm super excited already. Big community support and companies behind also so helping out this event happening. And I see some people from not only New Zealand, I see from Tokyo, a few people also from Canada. Nice to meet
That's
you,
awesome.
everybody. Yeah, I'm based in Tallinn, Estonia currently. It is Northern Europe. Now, the today's session is about Gen AI and generative feedback loops, because we all know, vector search, retrieval augmented generation, or RIG in short, in the last 2 years even became mainstream for building AI application, and everybody's thinking about what's the next coming, like AI agents, for example, or next some other frameworks are building on the top of Gen AI. Today's topic is GFL, Generative Feedback Loops, where AI can optimize and improve its own outputs over time through the source cycle of feedbacks and based on your production data. And then this can be used also for creating, let's say, AI applications for personalized recommendations or creating targeted ads, or creating even the more dynamic content. You will see in the next few slides some of the real world use cases. And then we're going to break down how this feedback loops works, models in this session. Let me introduce again myself like shortly. My name is Bobur. I'm a developer relations at Neon, which is serverless Postgres solution on Azure. And also I'm ex-Microsoft, also Microsoft MVP for Azure AI platforms. So feel free to scan this QR code. Let's connect on LinkedIn. I love the AI use cases, and we can, if you have any questions regarding session, I would be more than happy to address them. So let's focus on the topic. First, like, before understanding generative feedback loops, it is better to make a step back and then look at what is a RAG and how the RAGs works in short. Maybe some of you already know, some of you may be new to AI engineering. So in the RAG, how that works, simply it takes a user question or queries and search based on user question information relevant to that question, and including some retrieving information from data storage, from databases based on the question user asked, or we call it sometimes prompt from the user. As you can see, like you can use different models, like from GPT or Cloudy or DeepSeek. You just simply say, hey, please answer my question X. I'm giving information ABC, information which means you're feeding data into existing trained public LLM models. Like, because LLM models usually they are not aware of what's happening right now, or they don't know about your data. And this way you connect give some custom knowledge to your LLMs. This is how the RAG simply works. But if you look at this more closer, like typical RAG architecture looks something like this in the screen. As you can see, on the left side, you have some data sources, right, where you can give the AI input knowledge about your data that you want to work with. You can bring this data from different databases or APIs, or even some other existing tools like Google Drive, Slack, Notion. You can upload some PDFs, upload the voice AI video, some videos or audios, and then everything starts from that point. Like you build a pipeline for RAG, data processing pipeline, we call it, which means you didn't ingest the data, because usually the data is always large. If you think about the one even page PDF, it is hard to fit into LLMs if it's like more than, let's say, 100 or 1,000, let's say, rows. So your task is to split this big data into multiple chunks. As you can see, we have the PDF, we are splitting into multiple chunks, and we are pre-processing this data. Sometimes maybe we don't need to include some data, or we need to filter out user PII information or any privacy information before sending to AI. This is called the pre-process this data for every chunk. Once we have a chunks, one and two, etc., is coming, for every chunk in the RAG, we usually calculate the vector representation, right, by calling from our models vector embeddings endpoint, API endpoint, which is very popular endpoint. For every sort of data, audio or the text, we're going to calculate the vector representation. And then once we have a vector representation, we are storing this vector representation into vector databases. We can use existing also a database like Postgres, or maybe other that type of databases also has extensions for storing vector data, or you can use specific databases for storing data like ViewWeight or Pinecone. So to make it easier to work with vector data, this vector database, that is the only purpose of using it. And then it also makes it easier to retrieve this vector data when you're building a real AI applications. For example, once you assume that all these chunks vectorized and stored inside the vector databases, what do? You're going to build simple AI application. Let's assume you are building AI search tool, where you have just one search bar, like a Google search, and you have the backend application, maybe just a backend service with one API that accepts the user questions, what the user is searching for. Once the user question comes, what the client application part does, it calculates again vector embeddings from the user question, and then it does semantic search operation by going and comparing the input prompt with existing vector data in the vector database. Once it finds, for example, good matching, let's say I'm searching for some specific data in my academic research paper, then it finds the relevant information. After it found, it sends together with user questions and found the vector embeddings to another LLM model endpoint called chat completion, the second endpoint after embedding, to summarize this information. If user asks, show me summarize my academic research, it summarizes using chat completion and returns to the user back found information with some clearly explaining user-friendly output. To do so, you can use some framework like a LangChain or other type of frameworks that helps you to build GenAI applications. This is simply, it is how the GenAI or RAG architecture looks like from the high level. So once we understand this is how the RAG works, let's switch our focus back to our main topic, like feedback loops. So as you can see, like in the previous slides, when I say GenAI, generative AI, and RAG are actually also part of the GenAI, where you provide the additional information and knowledge to get more specific data from AI. As you can see, RAG primarily operated in one-way direction. It was generating content based on the input data we sent. And however, GFL also incorporates a feedback loop where our AI can continuously learn from the output it generates. Let's say output is generated from the GenAI, and we are sending back again as input to the same system. So feedback loops originally, as you can see, designed in a situation where AI content is used to train new models. You are using existing like a GPT-4 model, but you are retraining again with your custom data using the feedback loop. This is a simple architecture of the feedback loops. Let's say, what are the mechanisms nowadays exist in the feedback loop to create such solutions? Like, as you can see in the previous slide, there are feedback loops with training data sets. Like you train more with your own data set to generate some feedback loops. Or there are other way feedback loops driven by the human or the person AI interactions. Let's say in ChatGPT, if you're using also when you ask something at the answers and you have an optional to vote for the solution. Thumbs up means you are rating the answer is very good. Thumbs down is you're not confident with the response. In this case, AI can learn from your input and then next time can improve its response. This is a human AI interaction. And today's one, I'm going to show how to build vector feedback loops with the vector storage. How we can interact with vector storage to simulate these feedback loops to provide more accurate information to the output. Let's split this mechanism one by one. For example, feedback loops with training data sets. What does it mean? As you can see, we have GenAI model like GPT-4 or any DeepSeek I'm using, and then I am providing some additional corpus of data, my input data to the GenAI, and then it's continuously training its output. For example, you have Outlook emails, you are receiving always every day some emails, messages from your colleagues, from customers, and sometimes you can see file attached into it. So some maybe a rental agreement or some additional contracts with the company. In this case, this rental agreement can also change every time because it's content inside it can change by dates can change, or maybe the people involved can change. In this case, AI can always understand and then retrain the data to process next time similar rental agreement data easily. So this is like training data set information. You can also try these feedback loops with training data set already using Microsoft tools. Like I recently tried out new feedback loops preview feature for Power Apps and Power Automates in the Power Platform. There's a very good feature. I really like it inside the AI Builder. That's Power App platforms. They have an AI Builder where you can build your own feedback loop feature, which can help you to automate some continuous like works with the production data. Here I have a small kind of video recording I did myself, like by creating these feedback loops without writing any code, obviously. It's quite simple. As you can see, like in Power App and Power Automates, there are existing AI models that Microsoft provides us to reuse. Like you can extract information from invoices, OCRs, or you can detect some objects from the images. Based on the foundational model, you can choose any foundational model, but you can retrain this foundation model with your own data. Let's say I want to extract custom information from my custom documents, like rental agreement. So in this case, I can choose as a foundation extract information model, then train that data with my custom files. In this case, I uploaded my like 5 or 6 different formats of a rental agreement, and then this AI now can understand my custom document without myself like showing where's exact data. Once you specify and tag the information that AI should extract, in this case, it can extract the rental agreement information more accurately and even faster. For example, I want to extract like tenant name from the rental agreement. You need to first tag from the document, like you need to show the AI examples from 5 or 6 different documents where exactly tenant name is located. Once it knows the location, it applies some OCR or additional mechanisms to extract that information and send this information as a training data set to the AI model. So I will leave to you to try out this preview feature, or there are other places in the Microsoft products also you can see feedback loops also gaining popularity. So let's go next. Next mechanism, as I told you, like AI interactions. This is how the diagram looks like. In this case, AI is receiving some rewards driven by the humans. I think, and one of the good examples, like here, I recorded another the video. We were building like for the logistics solution, like data truck, sort of BI agent that converts human language into SQL, but AI generates unexecuted SQL queries, right, based on your the human send the data. So, but sometimes generated SQL is not perfect enough. In this case, we just put like a rating solution inside this chat where users can say if result correct or not, yes or no. If it's yes, which means resulted SQL is nice enough to use in the future. As you can see, we have some training data, and then we are also can analyze which the data is correct or not based on the user feedback. This is a user feedback driven feedback loops. So once this is clear, let's go to our main topic, like vector storage. We feedback loops with vector storage one. As you can see, it's quite similar to GenAI architecture. What's happening here? We have input data the same. I am first summarizing this data, like make it shorter because the data usually is big. I'm making shorter. If it's 10 sentences, I'm making 2 sentences. Then we're gonna calculate from the the input data, again, vector embeddings to store inside the vector database. So that's it. This is a 1, 2, 3, 4, 6 steps are pretty much the same as GenAI or RAG approach. But the only difference is, as you can see here, is happening when the production data is coming. We are doing this similarity search, right? Semantic search to find a similar the vectors based on the user queries. So once we found the matching, again, in this time we are sending this found the output both to the user application, and we are feeding into AI again to improve the AI data with the new information. As you can see in the red lines, I'm sending back to the step number 1, and then this is a not ending cycle we're introducing. Every time production data changes, we are know what exactly changed. We are calculating again vector embedding, summarizing, and storing in the vector database, so that we have up-to-date information to show the user at the end. So this is a simple diagram that explains the vector storage with feedback loops. So what are the advantages in this case, like of these GFLs? First of all, as you can see, it's very adaptable to new data. If you imagine there is no such mechanism, we had a vector store without updating information, always the same. Maybe you run some scheduled like a data extraction pipeline every day or every hour, but it doesn't change based on the event happening, right? Now, it's very adaptable. As you can see also through the repeated interaction between the vector database and LLM, we are reducing the initial AI bias. That's a very big problem in the models, right? And then errors in data can be also mitigated. And also we are putting it into this user feedback uh, uh, plus the production data, which gives us more personalized model outputs. Right, AI understands what do you want, what exactly your preference is in this solution, and then it will provide as output more personalized answers for future interactions. These are very top high level advantages, but if you go deeper, there are a lot of advantages you will find out. For example, the good GFL action in action can be personalized recommendations, like so Vera AI can suggest some products based on the user browsing history, clicks, purchasing. The same with Amazon website. You can see some suggested products on the top based on your location, based on the your order in the past, and so on. And the user further interacts with these recommendations, and AI can refine these suggestions in the future more in better way. Think about the real estate industry like Airbnb, if you ever use it. These property listings are always updated with new information, such as always price changes, availability changes, some furnitures added, and so on. But GFA pipeline here can help to automate and update the description of these listings. Descriptions, which means you just provide attributes of your apartment. We have 3 rooms, and this day are available, and with this price. And then GFL can update these descriptions in real time. You can just, forget about creating the description. AI can generate very beautiful descriptions for your the attribute listings, and then also it can optimize it for personas. If one persona comes and search for, show me a very cozy apartment in the center of Paris, and in this case, first we have a description, and then it's personalized, and it can quickly show and suggest to the user this optimized suggested information. Other real-world examples here I just found. LinkedIn can use this approach. Booking.com can use approach. Netflix, for example, Netflix, also it can dynamically adjust some scenes, movies, again based on your what you like. and maybe they are using different mechanism. Obviously, there are
Mhm.
other machine learning mechanisms, not AI
Yeah,
model mechanisms. I'm
yeah,
introducing now AI model mechanism. Then, or in Booking.com, for example, if I'm going to Redmond next week, it can suggest me some cultural experience information where I can visit, what other activities I can do. Even some Booking.com now is sending also. You have a premium access to use attractions in Redmond. Uh,
yeah,
but you can even like make it more personalized. So once this is use cases, there are more use cases, of course, in the real world. Now, the use case we are going to look at this today, it is called podcast recommendation. We're gonna recommend a podcast to the user. So because the podcast also changes over time. Think about it, you have a podcast platform, and then every day, like podcast authors, they are uploading in the new podcast, and then you
yeah,
also podcast categories, interest changes. Sometimes I'm interested in AI technologies or car automotive industry, and AI can recommend the podcast based on your interest. To achieve this, I'm creating just three simple APIs. Just one is we are thinking adding podcast. So maybe the mobile application, web application sending requests to the backend to add a new podcast. When the new podcast is added, with the podcast, for simplicity, we are not storing audio, but just transcription of this podcast. Generated transcription. Then we have another endpoint to update the user history, where user history, which means like from application, when user chooses favorite categories, choosing some AI, automotive industry, then maybe some other interested areas, and we are updating user history using this endpoint. And like last one is we are recommending podcasts when user just enters on the landing page. So this is the endpoint, and how that works, as you can see in the diagram, it's pretty much very clear. We have a podcast transcription, right? What we are doing, we're doing two operations. When this podcast API is called, first we are calculating from the transcript vector embeddings, vector representation of the transcription. Also, we are generating summary from the same transcript, where we are saying, hey, just summarizes like a long podcast and store in the database. The same we are storing transcription. Then user next endpoint, updating user history. We are the same, calculating vector embedding from the user preferences and storing into the database. These two steps helps us to with the third step. When user requests comes for the specific user ID, like show me recommended podcast, it is first fetching user listening history from the database, and also fetching the podcasts, finding quickly by comparing two vectors together uh, what user can listen next as a suggestion. As you can see, it's giving first output suggested the podcast to the user. At the same time, we are storing on the bottom uh, previously recommended podcast in the suggest podcast table. This additional feature, in addition GFL, but I leave it to you to implement the rest. But suggest podcast, which means like I'm avoiding to redundant recommendation that we did already in the past. We don't have to recommend again the same thing for the user, and then should recommend other things, for example, new things to the user, let's say, because why? Podcast, the same category of podcast can come. User preference also might change, but we can suggest different new podcasts always. And then it also gives us the way we can analyze the more uh, like we can do more analytics in the podcast, such as podcast table. Okay, user was watching last month this podcast, podcast top three for this user, and so on. A lot of statistics we can run on suggest podcast table, but the rest is real time. This is a typical example, like User had a history about some specific topics, and we are just giving output relevant podcast as a result. So this is, I think, is super clear. So now we can quickly jump on the demo part. I'm going to showcase how this works in .NET application. Originally, the application wasn't in a .NET, but I decided to make it .NET specifically for this meetup. I converted the application from Python to .NET. So if you scan this QR code, also you can find the repo. I already published it. You can also give a try yourself how that works. Try to run it locally. But now I can show you in my local machine how that works. Let me go to the VS Code. I think it's visible, right? It's
Yeah.
visible. And
Can you zoom in a little bit, and
yeah,
then we
sure, sure,
can.
sure. I will do. Yeah, I will do. I'm just checking. Okay. Of course, so we're gonna do what's it like? Yeah, okay.
Okay.
Or one
One
more zoom.
more.
Okay. Okay, good.
Yeah,
Uh,
I think that's
should be better now. We can just let me close this. Let's make it more. Yes, here we go. This is a typical .NET application. I'm using VS Code. Maybe we can start from the left side, from the
yeah.
project structure. Yeah, it's the REST API. I have a .NET application with some packages I'm using. Let's start with what packages I'm using. Okay, let's go to maybe the Azure Functions one. Azure Functions, maybe some of you already among us who is listening to the session, they know how to use Azure Functions. You can run it locally and deploy to Azure when it's ready to production usage. I'm using some extensions, packages to create Azure Functions in .NET. And on the top of like ASP.NET Core application, I'm running for this project. Then the rest is quite general. Like every time you create Azure Functions, if you're using especially VS Code, there is a special command. Like you can go to commands and you can say, for example, dot a new project. Also click on Azure function, create a new project. It creates a new projects by using templates. For example, you can choose your favorite programming language, then go other additional steps, and then it creates a project structure. Looks like this something. You don't have to write everything from scratch. Like it creates a program, a CS file, it creates a local setting JSON, and so on and forth. And in the program CS files, you can see I have some additional helper services like embedding service, chat completion service, and SQL service. This is the service located under common folder. For example, embedding service. Let's have a look. It's very simple because we need to use embeddings. We need to calculate vectors, right, from the podcast transcription. You can use other AI models, not only from Azure OpenAI. You can use, for example, public OpenAI or free models like Hugging Face and so on. You need to update here. Also, the client, you need to choose others, but I'm using Azure OpenAI. That's why, as you can see, the client also Azure OpenAI client. And basically, whenever I have some input, I'm just calling that API, Magic API, to get a vector representation. Another endpoint, the service, helper service is chat compilation, the same structure. And the client, OpenAI client, it's very helpful. We can like use some reusable components to calculate the completions and do other operations. And I have an SQL executor service that connects to the Neon database using the connection string. We have then it executes some SQL queries on the top of the database. Yeah, you can use entity framework, obviously, or I'm using just NPG SQL connection, NPG SQL the package to make it simple. And we have also the data should be somewhere here. Sample data to store podcast episodes, podcasts, and so on. Very, very simple databases at tables. For example, I was going to show you how this tables looks like on the Neon side as well, but you can use, for example, Postgres, the same SQL queries you can run if you're running Postgres like locally. For example, I'm first enabling vector extension for the Postgres because I need to store the vector data. And as you can see, I have tables like podcast episodes table, then users table, and suggest podcast, just 3 tables. And then as you can see, podcast episodes also storing vector embeddings and transcription together with some like a summary description and so on. The same way user storing listening history with the vector representation data. But of course, now if you a little normalize or even denormalize this table, it should be separate table. I mean, user listening history can become separate table. You can also make it separate to follow the best practice. And I have some users like with listening histories. You can insert, or even we can use the API to add these users to the tables. And here we go. And then I have these tables in the Neon side. I'm using Neon console. It's free to start. You can create your account for free and play with the Neon without managing your database locally. So as you can see, I have single database, empty tables, and I have the users, some data. This is the embeddings we're going to calculate now. It's calculated for one user, but to show you how that embeddings looks like, just the vector representation information. So this is pretty much on database side. Then I can get a connection string like from here. Like you can just get a connection string, or you can choose the programming language style of the connection string and copy that and put into your VS Code application environment. And in my case, I can show you. I have local settings with Azure OpenAI key. Some models I'm using 2 types of model, GPT-4, text embeddings. Then also database connection. This is database connection. I'm gonna remove anyway this API keys after the session. Just don't worry. If you have 10 minutes, you can just give it a try and try to hack stuff. It happens sometimes while you're doing. And then the main Azure function is here. Azure function. We have Azure Functions S with multiple. We are saying because we have 3 functions that uses these services. First, add podcast, update history, and then recommend podcast. It's a very simple implementation. You can also move this coding into service layer. Obviously, I was in rush, so I couldn't do everything in service layer. And then it's also not recommended, of course, using the SQLs like in this way. But the idea is to explain the approach, like how that works. Let's say, as you can see, we have some transcripts coming. I am calling both embeddings to calculate embedding, set completion to calculate the summary, and we are inserting the podcast table. And that's it. This is how the add podcast API looks like. Then when the user history update happens, I'm doing the same, calculating embeddings, updating existing user history, users table with the listening history. That's a string. I'm putting the string into the table. The magic part is here recommending podcast where this API is called with just the user ID. We are fetching first user. It is the user history embeddings, and then we are finding matching. This is a very kind of herd mechanism is only here. How we are comparing 2 vectors just in a SQL query. There's a magic like the symbol where you can put on the left side one embedding, on the right side another embedding to find similarities. This works with all the Postgres solutions. This symbol, the symbol can work only when you enable this extension. I previously showed. Create extension, and then that works to calculate and find a similarity search. That's it. And then when we find a podcast matching, I'm just putting inserting data inside this table. So let's run this application finally and to see how that works. I tried already before the session uh, uh, to make a quick test. So what we can do, just we can .NET build to build the .NET application. If doesn't, if something changes, and you see I have a lot of warnings. So I will improve this application again, like to make it more good on the .NET side. Then there is a specific command like func start for running your functions locally, or you can in VS Code you can also press F5 to run Azure Functions. These are very short commands. If you install Azure Functions core tool in your local machine, I put instructions how what do you need to install. I think we have one port is a PZ. Let me check. I think the thing I was running is still running the previously. Let me stop that guy. Then we can try to run again. Let's see. Oops. What's happening?
Yeah, the port's still being used.
Yeah, it's a Mac thing. All right.
Yeah.
Maybe I can try to change a port. That was somewhere I could change the port. Marcel, could you help me?
There was like a func start dash dash port 7072, for example. Dash dash port.
Yeah, let's do 7072. Huh?
Yeah.
This one. Yeah, this is, I think, okay, this is very, okay, cool. Thanks, Marcel. Uh, cool. Let's go back to terminal. Yeah, it's running now. Adding podcast, 3 APIs, it's up and running. Yeah, cool. And I have already prepared like a sample curl commands. You can just give a try and test to call these APIs. If you go to curlcommands.sh file. We don't that just we are adding podcast updating his history with some specific information. Let's run one by one these curl commands in the terminal session. I think this is a much better terminal session. Beautiful. I'm just copy pasting these to put my first podcast information. But basically, also in real projects, maybe you can connect to existing real podcast APIs to feed the information with more podcasts, with millions of podcasts. Let's say in this case, it works more efficiently rather than like working with only one or two data. It takes a couple of times based on like the model you're using, internet connection and so on. So it works for me quite fast. I'm still calculating probably vector embeddings of the given information. Let's see.
Yeah.
Let's wait a couple of. So it's not. I think it's calling, trying to call another port. Just about.
Yeah,
Sorry.
that's a 771. Yeah.
Yeah,
So let's
yeah.
see.
Because sorry. Yes, that's true. Correct. Otherwise, it for me like it works in 2 seconds.
Oh, cool,
Let's see.
cool.
And now, not 2 seconds. I think podcast. Yeah, here we go.
Yeah,
Yeah,
cool.
there are some code, but it's working. Future robotics. Yeah, and it's
Yeah.
successfully, and then we can verify that information going to the same table. Yeah, here we go. Yeah, the podcast is added, and then we have embedding added. Also summary. You see, this is the original transcription, but we have a summary also in place that summarize the transcription. Very good. And now I can run quickly updating that podcast with LIs, for example, user history. And user history also updated. And now I can try to get the recommended podcast for LIs. I mean, the user name, I'm just maybe Bob, just to get the podcast for that user. Here we go, you see? And then it's getting like one podcast we added previously as a suggested podcast for the Bob. Because Bob was interested in the AI robotics when we are getting robotics transform industries, some sort of a podcast with a similarity search 0.5, which means if it's above the zero point 0.5, which is like very close, almost real, a real suggestion. And in fact, like if you add the thousands of podcasts, you will get pretty much, I mean, not AI, right? You will get obviously similar, more podcasts as output. Cool. I think that's like a simple demo. I'm gonna demonstrate next level of this application. I'm gonna improve more to build a UI on the top of it, and then connect to the real
All right.
podcast API. Or we can also give a try with the other kind of real world use case. Yep. Let me go to the slides. I hope we are not running out of time.
Yeah, no, we got time.
Yeah,
Yeah.
yeah, and I'm working also. I'm not like working also creating some other Neon Azure RAG demos. If you are interested, not interested even especially Neon, but there are use cases on Azure and different programming language. You can visit this website. Maybe I can send also my presentation to Marcel. Marcel can share with everybody
Yep.
the slides. So there are good, pretty much good application using TypeScript, using Python, using different Azure services as a template or blueprint. You can reuse them. So
Mhm.
thank you, I think, for your attention. It was quite great to talk to Marcel. So if maybe if someone has a question, we can just jump on questions.
Yeah. Let's see like the audience is going to bring like some questions. I got a question. That was
Yeah,
like,
go ahead.
well, interesting. And like my question is about like those embeddings, right? So when you are comparing, like let's say there's like an existing embedding, and then you're updating the history, user history with new
Yeah,
embeddings,
yeah,
and then like you're comparing on that like particular select query,
yeah.
you're doing a comparison or like of the difference. But like what I didn't get is that like how is the embedding being overwritten or just retrained uh, on that flow?
Yeah, yeah, very good, Marcel. Question. I think this is a part I probably I missed it to explain. You are covering already. Thanks, Marcel. Embeddings are updated, for example, for user history. User history changes from X to Y via calculated embedding, just replacing vector embeddings with existing embedding. That's it. It's very simple, right? We are
Yeah,
overwriting existing embeddings.
yeah, correct.
There are other approaches as well. Like you can instead of overriding, you can put additional helper table to analyze other previous user suggestions. I mean user histories. Then maybe you do some magic semantic search operation better. But in my example specifically, yeah, we're just replacing. Then when it comes to selection part, because we're using PG extension, this magic
Yeah.
like the symbol, it can compare two different vectors to
Hmm.
find a
Yeah.
closer match. Under the hood, it use I think different mechanism because even you can specify in SQL configuration what kind of algorithm you want to use. There's a KNN algorithm. I think it's called nearest neighbor finding, like finds the nearest neighbor of the vector that's similar to the target, the vector. You can specify what
Hmm.
algorithm you want to use, or also even you can specify to get top three or top five output based on a similarity score. Let's say if you put three, you will get three outputs, and you need to choose one of them based on
Hmm.
the semantic search output. Uh, is that like answer to your question, or I can go go
It does
deeper?
like about the replacements, right?
Yeah,
Like
yeah,
other sort of flows in there, like there's kind of like this refeed mechanism where maybe like I don't know if that would be like a separate process that would be running that would just grab, let's say, the user preference and refeed that as part of the user query, like or yeah, I'm just like because I saw that you're replacing, right? But
yeah.
uh, I would assume that there would be some sort of process that would take the user previous user queries and the new embeddings and do like this sort of loop there, right? I don't know if
Exactly. Yeah.
it,
Yeah.
is there like a how it could be done as well?
Exactly. I mean, this is the how it should be, how it should be in reality. This is like only simple, the way I show it. But if you remember the diagram I previously like showed, the foundation is only I think this diagram is foundation.
Yeah,
This diagram is foundation, but you can of course like make it more, put more improvement on the top of it, like as you said, by considering the previous user queries uh, for the suggestions.
mm, yeah,
Yeah, but if to convert this diagram into the code, like it's pretty much like, you just start from easy one and then go and make it more advanced suggestion
yeah,
mechanism. It's also you saw, in suggested podcast table, I'm storing, but I'm not reusing it. In the code, there is another advancement I should do in also check suggested table, what suggested before.
yeah. Well,
Mm.
yeah, could be it. Oh, interesting. Yeah, that's I'm definitely exploring like the sample. Yeah, I really like that the comparison symbol in there. Yeah,
Yeah,
here's the
this is
invite
a
for others to explore as well.
yeah, this is interesting because it's typical Gen AI or RAG, but uh, we are a bit of putting on the top of the real-time data
Yeah,
without using real-time data frameworks. I would
yeah,
say it's
interesting.
just the approach.
Yeah,
In reality, you use some event processing solutions, or maybe you need to use Kafka to bring
hmm
calculate vector. In this case, quite simple, in combination of vector storage and API calls. If
yeah.
an API call should be also in some sort of in order to get the expected output.
hmm Well, I'm not seeing any other questions in here on the chats. I'd like just to thank you so much, Bobor, just for coming like on Monday morning and coming
It's my
sharing with
pleasure.
us like that. That's great content. Yeah, I'm sure it's going to be valuable like for well for me, for others in the chats as well. And it's going to be recorded, and then like yeah, others in the community will well use this as a reference.
Sure.
Yeah,
Sure, I would love to. I would love to. If invite me next time, I have other topics like more on how to build enterprise level, let's say, rack application
hmm
using .NET, something like that. I can bring
yeah,
that to the table as well.
yeah. No, that's great. Well, I think like we're just finishing here, but yeah, thanks so much, Bobor. It's been a
Thank you.
pleasure getting to know you. Yeah, I hope I get to see you next week.
Yeah, yeah,
Uh,
sure.
and then, yeah, for the community, we should have like other sessions coming in April. It's already booked. And yeah, thanks so much for coming here, staying online. And people are, yeah, people have learned something new in here. Glad
James,
that
thank you.
about the feedback, James. I learned something new as well. So really interested session, Bobor. Thanks so much.
Thanks for organizing, Marcel. Yeah, have a nice evening. Take care.
Cool. All good. Thanks, guys. Cheers.
Take care.
Catch you guys later. Bye.